Mrs.Abisha, Department of Computer Science and Engineering from Emmanuel Arasar JJ College of Engineering. Today we are discussing about formal specifications. Formal specification is a technique for the unambiguous specification of software. Objectives: to explain why formal specification techniques help discover problems in system requirements, to describe the use of algebraic techniques for interface specification, to describe the use of model-based techniques for behavioral specification. Then, topics covered: formal specification in the software process, interface specification, behavioral specification. Then, formal methods. Formal specification is part of more general collection of techniques that are known as formal methods. These are all based on mathematical representation and analysis of software. Formal methods include formal specification, specification analysis and proof, transformational development, program verification. Next topic is acceptance of formal methods. Formal methods have not become mainstream software development technique as was once predicted. Other software engineering techniques have been successful at increasing system quality. Hence, the need for formal methods has been reduced. Market changes have made time to market rather than software with a low error count the key factor. Formal methods do not reduce time to market. The scope of formal method is limited. They are not well suited to specifying and analyzing user interfaces and user interaction. Formal methods are hard to scale up to large systems. Next one is use of formal methods. Formal methods have limited practical applicability. Their principal benefits are in reducing the number of errors in systems, so their main area of applicability is critical systems. In this area, the use of formal method is most likely to be cost effective. Next one is specification in the software process. Specification and design are inextricably intermingled. Architectural design is essential to structure a specification. Formal specifications are expressed in a mathematical notation with precisely defined vocabulary, syntax, and semantics. Next, specification and design. This is the example diagram of specification and design. Next study is specification techniques. First one is algebraic approach. The system is specified in terms of its operations and their relationship. Next one is model-based approach. The system is specified in terms of a state model that is constructed using mathematical constructs such as sets and sequences. Operations are defined by modifications to the system state. Next study, use of formal specification. Formal specification involves investing more effort in the early phases of software development. This reduces requirements errors as it forces a detailed analysis of the requirements. Incompleteness and inconsistencies can be discovered and resolved. Hence, savings is made as the amount of rework due to requirements problem is reduced. Next study is interface specification. Large systems are decomposed into subsystems with well-defined interfaces between these subsystems. Specification of subsystem interfaces allows independent development of the different subsystems. Interfaces may be defined as abstract data types or object classes. The algebraic approach to formal specification is particularly well suited to interface specification. Next one is structure of an algebraic specification. First one, specification name. Sort by name involves list of specification names. In informal description of the sort and its operations. Operations signature setting out the names and the types of the parameters to the operations defined over the short. Axioms define the operations over the short. Next one is specification components. It defines the short and the declares other specifications that are used. Description is informally describes the operations on the type. Signature is defines the syntax of the operations in the interface and their parameters. Axioms defines the operation semantics by defining axioms which characterize behavior. Next one is systematic algebraic specification. Algebraic specifications of a system may be developed in a systematic way. Specification structuring, specification naming, operation selection, informal operation specification, syntax definition, axiom definition. Next one is specification operations. Constructor operations, operations which create entities of the type being specified. Inspection operations, operations which evaluate entities of the type being specified. To specify behavior, define the inspector operations for each constructor operation. Operations on a list ADT. Constructor operations which evaluate to short list, create, const and tail. Inspection operation which take shortlist as a parameter and return some other short, head and length. Tail can be defined using the simpler constructors, create and const. No need to define head and length with the tail. Recursion specifications. Operations are often specified recursively. Tail of const L, V is equal to if L greater than create, else const tail of L. Interface specification in critical systems. Consider an air traffic control system where aircraft fly through managed sectors of airspace. Each sector may include a number of aircraft, but for safety reasons, these must be separated. In this example, a simple vertical separation of 300 meters is proposed. The system should warn the controller if aircraft are instructed to move so that the separation rule is breached. A sector object. Critical operations on an object representing a controlled sector are enter, add an aircraft to the controlled airspace, leave, remove an aircraft from the controlled airspace, move an aircraft from one height to another, look up, given an aircraft identifier, return its current height. Primitive operations. It is sometimes necessary to introduce additional operations to simplify the specification. The other operations can then be defined using these more primitive operations. Primitive operations bring an instance of a sector into existence, add an aircraft without safety checks in space, determining if a given aircraft is in the sector occupied, given a height, determine if there is an aircraft within 300 meters of that height. Specification commentary. Use the basic constructors create and put to specify other operations. Define occupied and in space using create and put and use them to make checks in other operation definitions. All operations that are result in changes to the sector must check that the safety criterion holds. Behavioral specification. Algebraic specification can be some when the object operations are not independent of the object state. Model-based specification exposes the system state and defines the operation in terms of changes to that state. The notation is a mature technique for model-based specification. It combines formal and informal description and uses graphical highlighting when presenting specifications. Modeling the insulin pump. The schema models the insulin pump as a number of state variables: reading, cumulative dose, capacity, alarm, pump, display. Schema invariant. Each schema has an invariant part which defines conditions that are always true. The dosage computation. The insulin pump computes the amount of insulin required by comparing the current reading with the two previous readings. If these suggest that blood glucose is rising, then insulin is delivered. Information about the total dose delivered is maintained to allow the safety check invariant to be applied. Note that this invariant always applies. There is no need to repeat it in the dosage computation. Dosage schema. Thank you.